Hello, everyone. Welcome back. So we're going to do another critique of the coding challenge from last week. So thank you all for participating. It was really fun looking through all your submissions. So the problem last week was this. So you were supposed to buy low and sell high. So we're giving you a set of data in an array with a number of stock prices, and you're supposed to choose when to purchase the stock and when to sell it to maximize your profits. Okay, so we showed you two examples here. The first one, the example, the maximum profit would be 5 because you would buy at 1 and sell at 6. The second example, you would have no profit, no maximum profit, because every day the stock price goes down. Okay, and then we gave you a skeleton of a method that you're supposed to fill in. We pass in a parameter, which is a list of integers called prices, and then you're supposed to return to us the maximum profit. So I have with us today Ronald and Wilbur. So Ronald, tell us what were some of your thoughts about the submissions this week.
Yeah, so we picked this problem because we saw that there was quite a number of different possible ways to approach this problem. And we liked to give this problem to you because we wanted to see how you would solve it. Obviously, there's in last week's call, we kind of mentioned that there's the brute force method of really approaching the solutions with multiple for loops. And some of you definitely did that, but we definitely saw some of the more creative answers that were more along the lines of what we thought should be the solution. So love to go through it with you today.
Okay, great. Thank you, Ronald. And we also have with us today Wilbur. So Wilbur, what were some of your high-level thoughts on the submissions?
We saw the surveys that many of you want to try more algorithms. So we searched to see what kind of algorithm questions is suitable for y'all. And we found this question. Originally, we thought this could be a little harder. I wasn't sure how many of you would end up submitting, if we need to provide hints. And I was actually very pleasantly surprised that many of you seemed to do the question. And more of you than I thought also crushed it. So I'm excited to see what kind of more challenges that we will give you guys after this one.
Okay, great. Okay, thank you, Wilbur. Thank you, Ronald. So let's go and take a look at the first critique that we wanted to show. So this one here is from Aki, and this solution we said is order n squared over 2. Basically, what he does here is he has two for loops that iterates through the array. The outer for loop and the inner for loop. The outer for loop starts with the first element, and then the inner for loop then goes through all the elements after that first element and does the comparison. And so we just put a diagram that shows you basically what this algorithm does. So here it starts from 0 all the way to size -1. This is the outer for loop. Then in the inner for loop, it goes from I plus 1 all the way to size, and it compares every single element to the first one. And then the second time around the outer for loop, it does the same thing, but now it goes to the I plus 1, in this case index 2, all the way to the end, and so forth. Right? So it works, the code works, but this is the brute force method because it iterates through the loop quite a few times, through the array quite a few times. And it's order n squared over 2. So imagine if the array was 10 elements long, then the inner loop, the inner code would be executed 10 plus 9 plus 8 plus 7 all the way to 1. So it would be executed 55 times, right? So that's why we call it n squared over 2, because n here would be 10. 10 squared is 100, divided by 2 is 50. So it's around 50 times that it would for an array of 10. So inside Aki's code, he actually had a couple questions I want to throw out to our panelists here. Do long variable names take longer to run? Who wants to answer that?
Sure, I can take this one. No, I don't. In programming, variable names at the end they only change the file size because longer names are longer strings. But at the end of the day, when the computer converts the names to computer code, they don't care about the variable name lengths at all. It just becomes this thing and that thing, and both of these things have the exact same size. So the length of the variable names don't matter, but the number of variables you use does matter.
Okay, awesome. Yeah, great answer. I guess that's a good question, right? For someone who's maybe not too familiar with how computers work. So I guess what this tells us is that you can use descriptive names. Don't abbreviate it so short so that it doesn't make sense, right? Because it doesn't really impact the performance. He also had another question. Why did the last row take so long to execute? So in his run, the last row took a long time to execute. Any one of you want to address that?
Sure, I can talk about this one. So, like Roland was mentioning earlier, with the what we call big O notation, n squared over 2, because you're running over the arrays multiple times, with the last row in the input file, we had a very absurdly long string of numbers, essentially. So because you needed to iterate through each element multiple times, with a very long array, you can see this gets out of hand pretty quickly. So the key and the hint that we gave you last week was to try to iterate through the arrays less. So with anything that you're doing iterations through, the one thing you want to think about is to reduce the amount of work you need to be doing and traversing that array.
Okay, awesome. Thank you, Ronald. Yeah. So like we said, this algorithm was order n squared over 2. So if, let's say, the last data array had 100 elements, that's 100 squared, which is what, 10,000, right? So it grows exponentially. Okay, but good questions. Okay, so let's take a look at this other submission now. This is also the same, around the same performance as the previous one. But what I wanted to show here was that, again, there's 2 for loops, but the logic here is a little bit hard to understand. If we look at it, the first for loop iterates through the array using an index called day. So day from day equals 0 to day equal less than prices that size. And then the inner for loop has a new index called through, and it also iterates through the same elements, 0 all the way to size. And then inside that second for loop, it has this logic. If through plus day is less than prices that size, then it uses this new variable called no overboard equals through plus day. And then it uses that calculated index in the next if to do a prices.get. And then it uses that to compare against the day, and then to see if that's greater than the current profit. So it took me quite a long time, or quite a few minutes to actually try to unravel what this was. So it's pretty complicated until I finally figured out what this code was trying to do. And what I did was I took the opportunity to just basically rewrite it. Basically what the previous code was trying to do was this one here. The outer for loop would go from 0 to size. Then the inner loop would be from day plus 1 to size. So if you had written it this way, then you don't need that first if statement, and you can just do prices.get and use the through index. So it just simplified the code. I refactored it. It's easier to read. So that was just, I thought I wanted to show that here. Ronald and Wilbur, what are your thoughts on this code here versus the one that I refactored here?
Well, just off the top, I think the choice of variables definitely played a little bit in it for me. Just the variable names don't, I'm familiar with the problem enough that I can understand it. But if I was to come in not knowing what this problem was, I would take probably quite a bit of time to, really work through what the variable is doing. So this, I would say, is one example where choosing better variable names would help the comprehension of the code coming in.
Yeah. I literally took at least, I think 10, 15 minutes to understand what the code was trying to do. But yeah, for sure, better variable names. I guess I wanted to show this here too, because we always talk about reducing complexity, and in this case, it's not a lot of lines of code, but it's still complex because the logic itself was pretty complicated. The original code here, right? Well, if it had been refactored like this, then it becomes easier to read, because then we can understand what's being compared with what, rather than dynamically calculating the index here in that if statement. Okay, let's jump to the next one. So this one here is submitted by Ali. This is order 3n. So what's happening here is that so in the code comments, Ali said that originally his code was just whatever was inside the else clause. So that was his original code, and it works. It works just as is. But then he said he decided to add the additional code on top that searches for and looks for the minimum price and the maximum price in the whole collection. And then he does a shortcut in that first if. So the problem with that is that he actually made the code worse, because without his original code that was just inside the else clause, that was running at order n. But now that he's added these two collections in .min and collections.max, now the code runs at order 3n. And the reason it runs at order 3n is because each one of these, the first two lines, each one of them runs at order n. It has to traverse the entire array to look for the minimum, and then again it has to traverse the entire array again to look for the maximum. And then the else clause would then traverse the array a third time. So if you just had left the code as is with just the code inside the else clause, then you would have just traversed the array once and it would still give you the right answer. So has that ever happened to you, Ronald or Wilbur, where you kind of ended up over-optimizing your code? So your code worked and then you over-optimized by adding more code and made it worse?
Yeah, I'm sure it's happened many times. I just don't have a good example right now. But I guess the main thing that can happen is not realizing what the function call you're making could be doing. It happens a lot too. It's not really like, oh, it's Ali's fault for not knowing how it works. But like stuff like prices.index of, and then he looks for it. It's more of like collections.min. It's hard to just intuitively think, oh, collections min is actually on by itself. By looking at it, you might feel like, hey, it's magical. It'll just give me the min pricing. Max magically gives me the highest pricing. And it's easy to overlook what might be happening behind the hood that it needs to do to get those min and max values. And I will say this, in almost day-to-day programming stuff, you don't have to worry about these small optimizations. But for this challenge, it is important to take notice of these things for this particular challenge. But in the real world, it doesn't really matter that much.
Yeah.
Actually, this actually segues nicely into the article that I was reading today about the Grand Theft Auto load times, and basically in that article, and we can link it, is that the devs on Grand Theft Auto Online, they traverse a giant JSON collection of I guess, in-game like downloadable content or loot items and things like that. But the way they traverse it and parse the array, it uses the kind of built-in functions, but they don't realize the kind of time complexity and the performance issues that they cause through using that. And I mean, granted, like, you know, with better QA or in other processes, those things should be caught, and, you know, with bug fixes and things. But for some reason, this performance issue has been plaguing the game for a long time. And yeah, so this is kind of one of those cases where, you know, not when you're looking for code optimizations, you know, knowing what you're doing and I guess at a higher level what the objective is quite important, because, you know, not knowing the index of and what it's doing is probably okay, but then it's kind of, I think the bigger picture is that it's a redundant call, and you could have just done with the code inside the else block.
Yeah, good points. Yeah, so we'll provide a link. We'll add that to the video on the bottom, so you should see that. It's a good article. You can go ahead and read it. But yeah, good points. It's redundant code. But Wilbur also brought up a good point, is that in day-to-day code, we don't normally have to worry about the performance. Like, if you could look at collections.min, collections.max, you don't normally think, okay, this is going to take order n. And in most coding, it doesn't really matter because computers are fast enough. So, but this challenge is a little bit contrived because we wanted you to take into account the performance, where it doesn't normally happen, but in the cases, for example, like Grand Theft Auto, where performance does make a big difference, then it's good to know what is the implications of making these calls. It's just a one-line call, collections.min, but it actually has a big impact on the performance. Okay, let's move on to the next one. So this one here is submitted by Tyler. So this one is a little bit better. It's order 2n instead of 3n, and it's 2n because it traverses the array twice. So we have 2 for loops, and each one of the for loops traverses the array once. So the first for loop looks like it's trying to find the optimal buy price, and then the second for loop looks for the optimal sell price given that buy price. There's a couple of things that I noticed when I walked through this code. One is that there's some variables that were not needed. So the first refactoring that I did was, so in the original code we have current price defined in the outer scope, but actually current price is not used outside of the first for loop. So it could have been refactored so that current price is only defined inside the first for loop. But then if you look further, current price here is just assigned the value of price, which is what we're traversing on, right? So since we're just using it that way, then we actually don't need a variable. We could just use price on its own like this. So then we don't need the variable. Then it's easier to read, right? Because we know that we're traversing through the prices array for each price, and then we're using price as is. And then the next step I saw was that previous price is actually assigned here, but it's actually not used. So actually we don't need that variable. So we could get rid of it completely. And so after all that refactoring, this is the code that you would end up with. And it's a few lines of code less, but it's also easier to read. Okay, so that was just the comment that I wanted. It works. It works. It was just some extra code that was not needed.
I think more importantly is that by introducing all those extra variables, there is more chance for the variables to not sync up, or you forgot that which variable is what, or there's just more chance for bugs to appear with redundant variables. So if you can reduce those kind of unneeded things, then that's just better for your code.
Yeah. Okay, awesome. Let's move on to the next one. This one also was around the same performance, order 2n. This is from Mackenzie. So it's 2n again because it traverses the array twice, 2 for loops. The first for loop looks for the the buy price again, and then the second for loop looks for the max price. So min price and then max price, and then it returns the prices for max index and for min index. So it works. My main comment here is that we have two things that we're keeping track of, right? Minimum and maximum. But for minimum and max, for minimum, we have both the min index as well as the min value. So if you look at the first two lines here, we have two variables, min index and then min, which is the value of the array at min index. And the same with max, right? We have the max, which is the actual value, and then the max index. So those two are quite closely related, right? So if you recall from last week's critique, we talked about one principle of having a single source of truth. So whenever you have two variables like that are quite closely related, like what Ronald said, it's very possible when you have variables for them to get out of sync with each other. But min index and min should always be in sync, and as well as max index and max, right? And there could be a number of places in the code where you have to enforce that synchronization. And if you miss just one of them and they get out of sync, then that could potentially be a bug, right? So that was just my comment here. So I'm thinking, for example, if you said min and max is the source of truth, then in your final return, instead of returning prices.get max index and prices.get min index, you could just return max minus min. So yeah, that's my comment there. Okay, let's move on to the next one then. Okay, so this one was submitted by Bastian. So this one is order n. So that means it just traverses the array once. So that's really good. The only improvement that I could think of is that it traverses the array from index 0 all the way to the end. And it actually doesn't need to. It can start traversing the array at index 1. So that's a very small minor performance improvement, but that's the improvement that I could think of. Okay, any thoughts? Okay, then let's move on to the next one. So this one was submitted by Oscar. So this one is order n minus 1. So if the previous one, if Bastian's algorithm, if he started at index 1, then it would also be order n minus 1. And so here, Oscar starts the for loop at index 1 and goes all the way to the end. And then it's just two if statements, and it works really well. I had just a couple comments here. The first one is the naming of the variables. Diff is like a difference, but what you're actually doing is you're calculating the profit, right? So I don't know, maybe profit might be a better name for the variable. The second comment that I had was on the last line when you have that ternary operator. So you're comparing if diff is equal to -1. So a couple things popped up in my mind when I saw that. First is where did that magic number -1 comes from? I'm guessing, and I don't know, you can correct me if I'm wrong, I'm guessing that you ran the code through a few test runs and you noticed that there were some test runs where the diff ended up as -1, the final diff. And so you just embedded it in here. So if it is -1, then you would return 0. The problem with that is that you optimize it for this data set. But if a different data set, what if diff could return like -10 or -100? Then this code doesn't catch that, right? So it might be better to say if diff is less than 0, because and if we called it profit, then it makes a lot of sense, right? Profit should not be less than 0 because that was the constraint that we gave. But that goes to another idea, is that if you don't want profit to ever be less than 0, if that's not a valid value, then rather than checking it at the very end when you're returning the value, you should enforce that in your code. So you should never assign a value less than 0 in your diff or in your profit variable. So for example, in the first line there where you have prices.get1 minus prices.get0, that could potentially result in a negative value because we don't know what the values are for get1 and get0. So maybe you should enforce it there. So if diff never gets a value less than 0, then in your final return statement, you can just go return diff. So those are my thoughts on this one. Any other thoughts, Ronald or Wilbur?
Yeah, I think you covered most of it. Yeah, just same thing. It's if it works because the data set covers that could create a -1 at the beginning, but if it then it will slip through the cracks.
Okay, awesome. Okay, this one here is submitted by William. So maybe Wilbur, why don't you walk us through this one? I think you found a bug here, right?
Yeah. So this one was. Wait, sorry. Can you hear me?
Yes. Yeah. Go ahead.
Okay. So this one was actually a little bit difficult for us to figure out how exactly this can go wrong. But after looking at some more, the biggest thing you have to notice is the if x smaller than lowest. So if you look at that block, what happened if x is smaller than lowest? Then we set the lowest into x and highest into x. Pretty much it's saying that if we find a new lowest number, we will reset the lowest and highest. Now, in our data set, this is okay because we don't have weird situations where the last number or rather the lowest number is close to the end of the list. When this can break down, which was hard to figure out, was that the numbers reset when you find a new lowest number. This can have a problem if the lowest number is very, very close to the very, very end of the list. Let's say the second last two number. Let's just say we have an example list, which is something like first number 500, second number 1000, third number 1, fourth number is 2. By looking at this 500, 1000, 1, 2, you can tell the biggest profit is buying at 500 and then selling at 1000. The profit will be 500. But the problem if you feed this list through this algorithm is that, oh cool, it'll calculate 500 is lowest, 1000 is highest, get the 500, but then when it hits 1, it'll reset the lowest and highest number. When it hits 2, it will call max equals the new highest, which is now 2, minus 1, which gives you the profit of 1, which is not the correct answer. Our data set does not cover these kind of extreme cases where the lowest number happens at the very end and has a low profit afterwards. But yeah, it's something to be aware of. So how do you make sure this doesn't happen? Let's say you want to keep this algorithm and you want to not let this happen. Probably the simple, I see that the person who wrote this tried to do that with if highest minus lowest is greater than max, set the max. That is actually the right train of thought. If they had copied that logic with the first part, it would have just worked fine. The fact that the first part is sets max, it just strictly sets max. If they add a check, if highest minus lowest is greater than max, and then set it in both places, then it would have worked fine.
Okay, great. Thank you. Awesome analysis. Anything to add here, Ronald?
I think for our problem, because we didn't cover this in the data set, congrats. But in the real world, and most likely in when you're working, you will try. Okay, well, first of all, no one's going to give you a data set that is complete, so you'll need to think of edge cases that you might encounter. And this would be probably even more important if you continue your computer science kind of studies or you continue programming, thinking about edge cases will be more and more important. But in a production environment, if this is your job, things like this do happen. That's why there's QA people and there's bugs. But I think it is important to highlight that, even for your code that you write in your project, think about the edge cases that will not be handled, and that will get you, to a code base that is will handle the more unexpected situations, especially when the users go off that happy path and they do something unexpected.
Okay, awesome. So the good news is that we're not disqualifying your answer. We're still considering that you got the right answer. So you're still in the draw that Ronald will run. But I guess it's a good thing too. This is a lesson, and that what both Wilbur and Ronald said is that potentially this code could have been released into production and it wouldn't find a bug till later because the data set that we provided, which is our fault, does not cover the case where this code breaks down. So I have one comment, which is your second if was indented pretty funnily. It looks almost like an else if, that second if. So you should probably put that in a separate line. There's no reason why it should be indented this way. Just makes it easier to read. Okay, let's jump to the next one. So this one here is actually our last one. It's submitted by Irene. Ronald, do you want to just talk about this?
So this code is probably as quite close to the perfect answer as we are looking for, in the sense that we only traverse the array once, and we try to find the highest. We basically keep track of where we see the highest and the lowest, and we don't do any double work essentially. The only comment with this particular solution is that you could have started the counter at 1 instead of 0, because the first element is going to be the first price. So it's redundant. But other than that, I think this is probably the closest submission that we consider to be the solution that we were looking for.
Okay, awesome. Yeah, so congratulations, Irene. You get one sticker for being the solution that the three of us, Wilbur, Ronald, and I thought was the closest to the best solution. So I guess that wraps up the critique for this week. Thank you, everyone, for submitting your questions. So, Ronald, you're going to run through the test runs with the actual code speed, right? Tell us a bit more, and then you'll announce that at the Tuesday class.
Yeah. So, after this video, we're going to take all your submissions and run it 3 times. I will then take the best of the 3 runs the best of the 3 times that REPL gives me, and then I will input that into the spreadsheet, and then basically we'll just rank you from fastest to slowest based on how your peers do, and then we'll assign the points that way. So you should, by the time that this video is released, you should be able to see kind of the rankings on the scoreboard for week 4.
Okay, awesome, great. Okay, well, thank you, Ronald. Thank you, Wilbur, for doing this critique with us. And so everyone else, keep submitting these challenges. We have a lot of fun going through them, and we hope that you're getting a lot out of it as well. Okay, take care and talk to you soon. Bye-bye.
Bye.
See ya.